Rational numbers include integers, fractions, and certain types of decimals. In this video, we continue exploring different types of rational numbers and introduce the concept of irrational numbers. Let's start with an example. For what values of a and b can the values of c be rational numbers? What are some examples of c being non-rational? This is a right triangle. The corner is a 90-degree angle. These sides are known as the legs of the right triangle, and this side is known as the hypotenuse, which is labeled c. To calculate the value of c, use this formula. c equals the square root of the quantity a squared plus b squared. Notice that the calculation of c involves squaring the a term and the b term, and then finding the square root of the sum. There are some cases when the value of c is a rational number. Let's look at an example. In this example, the legs of the triangle are 3 and 4 units long. If we plug these values into the formula, we get the square root of the quantity 3 squared plus 4 squared. This becomes the square root of 9 plus 16. This becomes the square root of 25, which is equal to 5. So in this case, the value of c is a rational number, specifically an integer. Examples where the side lengths of a right triangle are integers are known as Pythagorean triples. There are other examples of these. But there are even more examples where the value of c is not a rational number. Let's look at one such example. In this example, the legs of the triangle are 4 and 5 units long. If we plug these values into the formula, we get the square root of the quantity 4 squared plus 5 squared. This becomes the square root of the quantity 16 plus 25. This becomes the square root of 41. But the square root of 41 is not an integer. Using a calculator, you find that the square root is a decimal value with an unending number of terms that do not repeat. This is known as a non-terminating decimal. Because the decimal is non-terminating and non-repeating, the number can't be written as a rational number, or the ratio of two integers. Decimals such as this are called irrational numbers. As an aside, some non-terminating decimals are rational numbers. For example, 1/3, which is a rational number, when written as a decimal is 1.33, with the 3 repeating infinitely. It is non-terminating, but it is also a repeating decimal. Some rational numbers can be written as repeating decimals. When a decimal is non-terminating and non-repeating, it is an irrational number. For example, the square root of 2. Let's look at another example. Is the ratio of the circumference of a circle to its diameter a rational number? Not all ratios are rational numbers, as this example will show. Here we have the ratio of the circumference of a circle, c, over the diameter of a circle, d. Are there any cases where there would be an integer in the numerator and one in the denominator? The formula for finding the circumference of a circle is pi times the diameter, as shown here. This means that the two d terms divide out, leaving pi over 1. Is this a rational number? Well, 1 is an integer, but pi itself is not. It's an irrational number. In other words, a non-terminating, non-repeating decimal. Here is pi to the 10,000th place, but its decimal values extend to infinity. So the ratio of c over d simplifies to pi, which is irrational. So this ratio can never be rational.